Hey, hello everyone. Welcome to this first ever lecture on Introduction to Docker, an open platform to build, ship, and run distributed applications. We'll try to cover all the important topics and concepts related with Docker and get whosoever is watching this. Welcome to this exciting journey. It's going to be really, real quick. We are going to cover all the only the important points. This is Gogo, our personal assistant, our personal friend. He's going to keep on coming in between sessions and trying to explain how he got to know about Docker, and he's going to take us into this intensive learning walkthrough. So let's Docker. So Gogo had a first day in his project. He thought that is going to be exciting. He'll impress everyone with his skills, and luckily he got the first task. So the first task he got was without any KT. KT is knowledge transfer. Any setup. OJT is on-job training. He didn't got any of this, and he was directly asked to work on a project which included PostgreSQL, HBase, Ubuntu, Node, Jenkins, all the latest tools, and the team, the management expected, the team expected that Gogo knew all this, how and from where to get all these things and start working. So now Gogo is tense. Gogo thinks that he was too confident because he's stuck right now. He is not aware about where to find all these tools and how is he going to integrate them, because every software has different configuration. Every app will have certain libraries, dependencies, OS requirements, hardware needs, etc. So there are the challenges are many, because as Google in the last slide said that there are a lot of dependencies, there are a lot of libraries, there are a lot of different OS which different softwares work. So when we are trying to integrate all these different applications together in one place, it is considered a matrix from hell, because we are not sure what will be the infra configuration, what will be the version, which softwares will be used, exact softwares will be used, which kind of environment are required for running my code, for running Gogo's code, and also once I, being a developer, consider that I've created the code, I have generated the code, the build was successful, but am I sure that that part of code will be migrated smoothly and quickly to higher versions in future, or if there are any hardware changes in future, for example from 64-bit to 128-bit, like which is right now physically impossible, as 64-bit can address 16 billion GB memory, but we still need to give it a thought. What if there is a hardware change? Is my code compatible to that? And also, most importantly, all these services and apps that I'm going to use. For example, it can be front end, DB, queue, APIs, OS operating systems, and everything. All those services and apps, are they going to interact with each other properly or not? And what if I write my code and that code has to handle a lot of traffic? So do I have the freedom to scale my entire system to as many instances as I want to handle that huge traffic? There are so many concerns, there are so many confusion, there are so many questions when we try to code, when we try to do something from scratch, which Gogo was assigned here, and that that gobsmacked and confused Gogo, and he was trying to find out what and how is he going to come out of this. There's another problem as well, like which all the developers in some or the other part of their life have come across. Like uh, I have done my coding, my code is working fine, but what if, like many times it happens that my code works fine, build was successful, but when I give it to the tester, it fails. It crashes due to maybe configuration issues, because of the version issues. But every developer has this question in the back of his mind, that will my code will be deployed successfully in their environments for testing and debugging without any compatibility issues. Because if the tester fails to test the code, even if it is because of configuration or version, the code will be returned, which will be really frustrating, because you have given your sweat and time, and still it was rejected just because of some different reasons which is not under your control. So in order to solve all these problems, we came across a very big wider concept, which is of DevOps, which is development plus operations, combined dev and ops, of which Docker is also a part is also a part. And if you see the screen, you see a container. You might have heard about containers earlier too. Docker is a container system for code. It works on containerization. Now, what is containerization? Containerization is a system of intermodal. Like, this is a really old concept of containerization, not in the developing world or the software world or coding world, but this is an entirely different concept. Containerization is a system of intermodal freight transport, also called as shipping containers, where every container in a dockyard have standardized dimensions, so they are unique, meaning every dimension container is assigned to carry specific things. So they can be loaded and unloaded, stacked, transported efficiently over long distances, transport from one mode of transport to another without being opened. Also, all containers are numbered, which helps in tracking them. So Docker, as it says, Docker is a container system for code. So Docker is based on similar concept. Every software application is converted into a container with only required dimensions. That is, the required library files and dependencies are kept in a container, which can be copied, used, and if the purpose is done, deleted. Also can or it can be deployed wherever we want. So Docker is a container management service. The keyword of Docker says develop, ship, and run anywhere. The whole idea of Docker is to easily develop applications, ship them into containers, which can then be deployed anywhere. So here, the problem that we had was many, but now all the softwares, every software is brought into a container, and they have, every container have all required libraries and dependencies which is needed by that specific software or application, be it a web server, database, messaging, orchestration, any specific entity. If it wants to run it, a container will have all the required necessary libraries, binaries, which will help it to run, which makes container best thing a developer can ask for. I mean, like, you can just build once and that part of code runs everywhere. Every app runs in their own isolated container, so you don't need to worry about various versions of libraries and other dependencies for each app. Isn't that cool? So developer loves Docker because you build just once and it runs everywhere. It has a really good portable runtime environment for your app. You don't have to worry about missing dependencies, packages, other pain points. You can run every app in any of the in any of the platform, in any specific place, because all those apps have their own isolated container. They don't require to be dependent on any other softwares or libraries or versions. So you know all these points which are pain point for a developer was solved by Docker, because of which developers love Docker. Now here Gogo is trying to show off that, yeah, he finally knew what specific technology or tool will take him out of this problem. So now the next question that arrives is what Docker is doing when this specific thing which Docker is doing right now, which is it is letting you run a specific software, uh, not being dependent on the hardware or the versions and everything. And like Docker is doing just something which VMs, which is virtual machines, did via virtualization. So you may ask, what Docker is doing is already being done by VMs via virtualization, isn't it? And the answer is yes. Docker, which works on the concept of containerization, is also a type of virtualization, but there are several benefits of using Docker. Virtualization basically is the technique of importing a guest operating system on top of host operating system. Now here, if you see, there is a host operating system, and on the top of it there is a hypervisor, which is a VM, and on top of that we have a guest OS, which is your guest operating system, and on the top of that we have the binaries and libraries, and then on top of that we have application. So you see, like my laptop already has Windows 10, but I also want to use operating system like Ubuntu. I want to use as Windows 8. I want to also use a Red Hat, but my hardware will not support if I install so many operating systems on my main server, my main hardware. So what I will do is I'll launch VM for all other OS, and this technique was a revelation at the beginning because it allowed developers to run multiple operating systems in different virtual machines, all running on the same host. This eliminated the need for extra hardware resources. But as we know, technology keeps on improving. धोनी गया तभी कोहली आया. So containerization is better than virtualization. You may ask why. Well, containerization is the technique of bringing virtualization to the operating system level. So if we come to this part of the site, virtualization here brought the abstraction of hardware. There are several different operating systems, but we have just one hardware. The server is the only hardware that we have right now, but there is one host OS, and there are 3 different guest OS which are running on this one server, which is kind of an abstraction of the abstraction to the hardware. But Docker went one step ahead, and it brought the abstraction to the operating system. So in this, there is server, there is host OS, both stay common because these are the basic requirements of any machine. Consider your laptop. You will have your server i5, i3, i7, and then you will have an OS, could be 7, 8, 10, Windows, or if you are rich, you have, or you believe in quality, you'll have Mac. So Mac will have its own Mac OS. But if I want to launch a lot many OS on my machine, instead of going for virtualization, I will go for containerization, because there is just one layer of Docker, and this one layer of Docker is helping all these different applications to interact and run on my machine isolated, in an isolated form. So the cons, I mean, like, what are the drawbacks, which led way to Docker enter this market, and why virtualization was no more considered as that effective as containerization, is because running multiple virtual machines in the same operating on same host operating system led to performance degradation. And like, consider you are running so many operating systems. Okay, you are giving a way to run a lot many operating system, but because of the guest OS running on top of the host OS, both OS had their own kernel and set of libraries and dependencies. This takes up a large chunk of system resources, that is hard disk, processor, and especially RAM, meaning you launch VM on your laptop so you can run some other application faster on it, only to realize that everything got slow. Also, one major problem with virtual machines which uses virtualization is that it takes almost a minute to boot up. I work with VMs in real time at work, and sometimes it is torture to deal with them. On the contrary, Docker has bare minimum. If you see from the graphic fed, the Docker has bare minimum binaries and libraries, and containers are being on the same OS kernel, which is lighter and smaller. Also, utilization of resources is way better compared to VMs, as there is no guest OS and they use just host OS. So there is a huge upliftment for running different services, softwares, applications by having just one host OS and laying a platform and then running all the applications on top of that. On the applications, all OS, all services, anything, just on this. This is kind of another revelation which we had when Java came into, when there was just C++, and then Java came into picture, and it brought this platform independent thing where you just need to provide JRE or JDK, and then you can run any Java application on that machine. So similarly, this is the same. You have a server, you have host, you are laying down a Docker virtualization, and that Docker virtualization is helping you to run any amount of applications or services on top of the host OS. So coming to, I've talked about we have talked about a lot of containers. So what are containers? Containers are basically running instances of image. We'll come to this part of what is an image and what do you call running instances of image, but containers are basically operating system level virtualization. As we said, containers are operating system level virtualizations. It allows you for multiple isolated user space instances. They all share single kernel, and they can be added or removed anytime. So now Gogo is happy because he's not only found a solution for his problem, but he has also found an upgraded version of solution, which is way better than what people used to have, which was VM. This is a slide of all the differences. You can go through it if you want later in the video. Similarly, for containers, we have already discussed about all this part, that the containers are operating system level virtualization. They share single kernel, can be added, removed. It consists of a self-contained Linux file system, can be from any Linux distribution which is compatible with the host single, and right now this is basically used in cloud computing. Now let's talk about what is Docker. How does the Docker lifecycle look like? Now, you would have heard about GitHub repository. you pull the code base from the central repository or central space, and it is available to all who has the access to that repository. Similarly, if people who are working in corporate offices, they would have come across the 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 tool of Perforce. That's also similar to what GitHub does. Perforce is also a repository, and similarly, similar to GitHub and Perforce, we have Docker Hub, which is again another repository, which is the main repository. And when you try to pull an image from this repository, it comes to your Docker local server. When you run and when you pull this from here, when you pull this, you are actually pulling an image. So those are all Docker images that you pull from Docker Hub, and when you run that image, it becomes a container. So in short, running instance of image is container. And now you can stop, or you can start, or you can delete, or you can keep creating new instances of this image, which is new containers, until this image exists in your Docker server. Once this image is deleted, you can again pull it back from Docker Hub, and you can do the same thing again. So now Gogo looks happy because he was worried about tester. So now he knows that he can pull all those tools, all those applications from registry of Docker, write his code, then push it back to Docker, and this tester can pull it back from here, run the code, test it, and give the approval that whether the code was good or not. So it does not have now Gogo does not have to worry about will it work on his environment or not, or if the versions are good, if the configuration is good, and if all the other part of worriness is good or not, because he now knows the flow. He now knows how Docker system works. Now let's talk about Docker technology. Now, Docker technology is dependent on three major pillars: OS level virtualization, which we saw in earlier slides. We can run multiple isolated Linux containers, be it Debian, Ubuntu, Fedora, CentOS, all of them on one single host of Docker platform without increasing any load on your hardware or OS. Isn't that great? And Docker heavily relies on cache memory. Layer caching is another most important feature. We will learn it in our further sessions. But Docker layer, in Docker, each layer is mounted on top of previous layers. As you can read, each layer is mounted on top of previous layers, which are immutable, which can be shared across. Currently, we have base images like the ones that I mentioned earlier: Debian, Ubuntu, Fedora, CentOS, etc. The top layer is the container, as you can see in this image, on which we'll be working throughout the session. This is kind of something which you would have, which you can relate it with data types in C++, C and C++, that you have the primary or primitive data types, and you have then derived data types, and then you come to user-defined data types. So containers are our user-defined data types, where we will be using the image. These base images are the ones which are already present in the Docker Hub, which we'll be using at the reference. Those are parent images. They are immutable images, so we'll be using them, and then we'll create our own user-defined data types, which is our containers. I mean, like we can run those images, we can make changes, we can create new images, and then we can push it back to the Docker Hub. Now let's quickly go through the Docker architecture. I mean, Docker uses a client server architecture. The Docker client talks to the Docker daemon. This is the client. This is the daemon. And then daemon does everything. Daemon is like the heart of Docker. It does all the lifting of building, running, distributing your containers, everything. The Docker client and daemon can run on the same system, or you can also connect it with the remote Docker daemon, which we will be seeing in the future lectures. Uh, Docker client and daemon communicate using a REST API. Now, if people for the people who are not aware about REST API, I'll quickly give you an overview. Well, REST API is representational state transfer, which is a client server HTTP call. If you go to Google, if you type graph.facebook.com/ I have mentioned here YouTube, you can give your own personal user ID, and you should have the access token for using this REST API of Facebook. The REST API, when you put this URL and then you press enter, the REST API of Facebook gets called, and it will return you a JSON response like this, which is key value pairs like this. If you want to see, for example, and as I said, the YouTube, if you want to see, for example, instead of YouTube, you have your own user ID, and you want to see what is your ID and what is the name and what the amount of likes that your page has. You can just directly write this in this format, and it will be returned in JSON format like this, where the ID will be returned with its corresponding value, with name will have its corresponding value, likes will have its own corresponding value. So every website exposes some API which can be used to get data from their website, and then can be exploited to whatever extent you want. So that's the REST API. That's the concept of REST API.
Talking about server now, server, as the name itself says, it is the most important part of the entire Docker structure. It contains Docker hosts. It will be storing containers. It will have images. So it is going to do all the heavy lifting part of building, running, and distributing containers. Whereas registry, as the name itself suggests and answers, that it is the place where it will be storing entire images, all the official images by Docker, and also new images which we will be creating once we are very well versed with Docker terminologies, and we are good with the Docker commands and everything. We will be storing our own images, our own customized images to the Docker registry. So in future lectures we'll get to know, we'll definitely try to understand in much better way how the client and the Dockerized and registry, these three different entities, interact with each other, and give us what the Docker is all about.